Hi there, I'm recording for Module 2 test. This is problem number 7. Problem number 7 says, convert 100.0 degrees Kelvin to degrees Celsius and to degrees Fahrenheit. The first thing we need to know is that degrees Celsius, is going to be Kelvin minus 273.15. So that means that's going to be negative 173.15, right? 100 minus that, but we can't, we have to look at our precision, and here we're precise to the 10th place. So here we're going to round to the 10th place, negative 173.2 degrees C. Okay, so now we have to figure out the Fahrenheit conversion. So the equation given us in the text is the Celsius is Celsius is 5/9, Fahrenheit minus 32, open parentheses, Fahrenheit minus 32, close parentheses. So to rearrange it, we're going to say Fahrenheit multiplied by 9/5 is 9/5 Celsius plus 32, right? So Fahrenheit is going to be 9/5 times negative 173.2 plus 32. So 5, I'm going to do this, goes in here, 3 with 2 left over, 4 with 3 left over, 6 with 2 left over, 4. Multiply by 9. 9 times 4 is 6, is 54 plus 3 is 7. Carry the 5. 9 times 4 is 36 plus 5 is 41. 27 plus 4 is 31. So we get negative 3, 1, 1. Okay, so we have, okay, so here we have to look at significant figures. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's too many, so we're going to say negative 311.8 plus 32, which is basically going to function like a, you know how to add and subtract negatives. So here we go. 8, and it's going to be 9, 279.8. So it's the right number of, and this is negative. It's the right number of significant digits. 1, 2, 3. All right. So we don't need to worry about the 32 in terms of significant digits. That's exact. We don't need to worry about the 9/5 in terms of significant digits. That's also exact. So we're just looking at this C. So we had 4 significant digits, and that's what we want to have here in our Fahrenheit. And so the degrees Fahrenheit is going to be negative 279.8. Okay, so that's the answer for number 7. So I'm going to move right on to number 8 and not stop the video. Not stop while we're on a roll. Okay, this is a long one as well. So the specific heat of plastic is 50 times larger, oh, this is not a long one, than the specific heat of lead, and 10 times larger than the specific heat of stone. Okay, so what do we mean by the specific heat? The specific heat is the amount of energy that it takes to raise 1 gram of the substance 1 degree Celsius, right? So for different substances, it'll be a different amount of energy that it takes to change the temperature, okay? So the largest specific heat is for the plastic. Okay, let's say the specific heat of plastic is okay, so P is plastic. Plastic is 50 times the specific heat of lead, right? And it's 10 times larger than the specific heat of stone. Okay, equal masses of lead, plastic, and stone have the same initial temperature. and they're given the same amount of energy. Which ends up the hottest? Now remember, the specific heat is the amount of energy it takes to raise 1 gram of the substance 1 degree Celsius. 1 Celsius. Did I just say Celsius? It's Celsius. Okay, so the one that is the hottest is going to be the one with the lowest specific heat. And the lowest specific heat is the lead. It is the smallest of all of them, okay? So the lower the specific heat with the same amount of energy, that one will get hotter. Okay, and I'm going to do number 9. So number 9 says, many recipes call for cooking food at a very constant temperature of 212 degrees Fahrenheit or 100 degrees Celsius. Why do these recipes recommend that you boil the food to achieve this constant temperature? Now, I'm just going to say, as someone who's been cooking for decades, I have never followed a recipe that tells me to keep it at that specific temperature. It just says to bring it to a boil and keep it at that temperature. So, most recipes don't call for cooking food at a very constant temperature. They just tell you to boil it. But the fact of the matter is, what this question is getting at is the scientific fact that if water is boiling, okay, then it is 212 degrees or 100 degrees Celsius. That is the boiling temperature of water, okay? So that's what that is getting at. So boiling water will remain at 100 degrees Celsius or 212 degrees Fahrenheit. And I am going to do number 10. A 10.0 kilogram copper skillet. No, I'm not going to do number 10. I'm going to do that separate video. Sorry.